Good afternoon to everyone across South Africa, and welcome to our very first Civil Designer Software Technical User webinar, broadcasting live from my head office here in Cape Town. My name is Charles Scott, and I'll shortly be joined by my colleague, Andrew Cole, who will be demonstrating our latest roads design functionality, all incorporated in the current version of Civil Designer, version 8.1 Build 5. At the conclusion of our webinar today, please send us an email at info@civildesigner.com should you wish to arrange a focused on-site or online interactive user group. This user group can be based on today's demonstrated roads functionality for your individual team or office. Welcome, Andrew.
Welcome to this Civil Designer webinar. Today we're going to be covering some of the new roads functionality that has been added recently. Firstly, I'll work through a road widening project using the extract strings from CAD method. And included in that session will be a new median condition. We're also going to work through the Layerworks from CAD, the adding of components to your road, and then I'll also look at the variable height retaining wall component that you can add to your cross sections or to your template. The second project, I'm going to use a strings road. It's a normal cross section road that I'm going to convert to a string road, add an intersection, and then also touch on the new linear bell mouth grading. And then finally, we're also going to have a look at the automatic junctions, automatic intersections, and the water film thickness Sheetflow Analysis function as well. So what you guys should be seeing shortly on your screens is our road cross-section, a Civil Designer road cross-section, or road design shown in the Celebri BIM viewer. This is basically an export out of Civil Designer. With the new Civil Designer IFC file export functionality, you can export all your geometric data out of a project as one or more IFC files to be used as part of any BIM workflow process. IFC files contain 3D watertight solid model geometry representations of the project's objects with various IFC properties and quantities attached to the 3D model. Okay, I'm just showing you over here. This is the export in the CAD module, the export to IFC file. Okay, and you can select which parts of your project you'd like to export. There's an option to negate coordinates, export roads as separate files, and then also break it up into your IFC segments, segment lengths for the export. You've also got an option of various file formats. The 4.1 IFC file these days is the one containing the 3D elements. Okay, so that's been added and quite a lot of work's gone into that BIM compliance IFC export. Okay. All right, so I'm going to move on to this roads project. This is a dual carriageway project. It's a rehabilitation project. We're going to use those regression functions of ours. I'm just selecting my road file to work with, and then just running through the control panel. So remember, you guys can save these road control panel settings. It's an RCP file that you can save, and you can always reload it later on and use it for similar roads. So it's essentially those layer settings, these layers that you'd want to save, and then also your display settings. If you're displaying a lot of plan layout lines, it'd be useful to keep those. Okay, so we're going to start this. I just want to open up the control center. Okay, that's the new control center that we can then pin open, and then we've added a extract strings tab at the bottom, which then allows you to select your road strings that you'd like to work with. This particular road, the stake line's already been extracted, and then you can see the cross sections have also been extracted all along that stake line. There's a yellow and white line indicated on the cross section, and those are inserted with the road furniture functionality. We've had that in quite a while, but not all the people are aware of it. So you basically link a source CAD layer. So you'd have a line in the CAD layer, and then you can link your symbols to that, either on the left-hand or right-hand side. The heighting is done from a road cross-section layer. Okay. So that can be quite a useful function to make use of. Just the drawing where those symbols come from is a cross-section symbol. It's in the knowledge base software Civil Designer folder. So you can always add your own symbols into that drawing if you need to use anything that we don't have in the drawing at the moment. Okay, so going back to my road rehab, we're going to now define those road strings, the road strings. So I'm just selecting the left pivot on the source button. It's going to be interpolated from the DTM surface. Okay, and then it's going to prompt me to select the CAD entity. So that's my CAD entity. I extract the string. And then the right pivot, same, interpolate from your DTM surface, extract that string, and then I'm just going to run through the left road edge. All of those heighting surfaces are from the survey of the existing road. Okay, so we're just carrying on extracting each string, and this is a dual carriageway, so we've got the pivot strings and the median strings, in this case in the same position. Okay, so all of them are now defined, and you'll see that they highlighted in red. So if there's anything in there, any string, road string that's in red in this extract strings box, it then means that you can then recalculate it. Okay, so I'll run that road recalculate now. And those road strings now are linked to the CAD lines. And as you can see, there are quite a few options as far as the extraction settings go. If I view the cross section, it's using section graphical edit, you can see that road cross section is following the existing ground, the survey of your existing road. You can view, there's my Layerworks now, from the white line to the yellow line. Okay, and then that median drain has also been inserted from the existing median drain. So I'd like to also then touch on those new median conditions. Okay, so I think let's just go to the tools. If I go to tools, template paths, and I'm going to right click on our existing template and go to the template editor, and then as you can see, dual carriageway template, and we're just going to look at the new median functionality. I click on that median button. So that median join and the lower and upper median slopes have been given a few additional functions or options. You can see that's just going to run through straight through from one median breakpoint to the other. You've got a slope on each side, and then you've got the slope, and then once it touches to the ground line, it'll follow the existing ground line. So that's the one that we saw in our cross sections. And then those lower, upper, medium, you've also got an additional option there. So the one would be straight, and that's the one I've got on the left there now. So the one is straight and then the other one's the slope. So it's straight and then it's still intersecting with the ground line. The other one is just running a normal slope. Okay, so those two options, cross full grade and then the previous grade, and then you can also type in your slope that you would like to use. There is also on the dual carriageways, I haven't got an example today, but we have added the crown dual carriageway option as well. And remember, with the dual carriageways, you can actually model single carriageway roads using that dual carriageway functionality. Gives you a whole lot of additional options when it comes to modeling your roads. Okay, there I'm just showing you the extract with the slope with the extract. Okay, so I'm closing that median condition, closing the template. We're going to move on to the road widening. Okay. Okay, just once again to look at the cross section as it has intersected with the existing median. So that median condition just follows that survey that we've used for this rehab. Okay, for the road widening, I've got two existing CAD lines, the proposed widening, and in this particular example, if I zoom in at chainage 1600 to 1700, I've defined a named viewport there, so I just zoomed in a bit quicker. You'll see those CAD lines are already drawn. I'm just going to show you the cross section, and then let's just make road line 2, the cross section layer 2, our active line. I just want to show you the naming of your road strings. So if you ever want to inquire what they are, you can also go into the cross section and make that your layer 2, the design layer, the active layer, and then you can edit points to see what the names are. Okay, so let's switch on those CAD layers. So it's the proposed, it's both these widenings on the left carriageway. Okay, so it's the median and then the road edge. Those are two polylines that have been drawn right through that widening section. If I had to show you that in the cross section, let's just have a look. I'd maybe just show you those new added lines in the cross section. Okay, so you can see from the road furniture there's that new CAD line represented over there with that new and the arrow text. Okay, so we're going to be widening to that point, and then we're going to use that retain cross-full, the existing road string, to keep our cross-full of the existing carriageway. Okay, so now we're going to redefine the CAD line to extract. So select entity to target, and this is the left road edge. Extract string, and then I'm doing the left median. Select that string, select entity to target, and then select the CAD entity, right click extract. Okay, so those two are now highlighted in red. I can just show you those extraction setting options. Okay, so we want to retain the existing crossfall. We've got an edge level option, and then you can use the current road slopes, the string slopes. I'll just check the left road edge as well. Okay, so they're red. I can recalculate, and let Civil Designer do its thing. We should then see the widening happening in the just below chainage 1600 there. you can see the widening was into the median itself. So there I'm showing you in the cross section, that's that widening of the median into the median, and then on the left edge we've widened up to that new point using that retaining the crossfall or the current string slope option. So that's a very useful function, obviously, to get your designs out a lot quicker. This is basically the regression extract strings, but we're just doing it out of a different tab now. And you can keep track of exactly where you are with that extract strings tab. Okay, then we're going to look at the Layerworks for those additional layers that we've just added, the widening that we've done. So if you look at that function, it's the extract Layerworks from CAD under regression. Okay, so we're going to incorporate that into our volume calculations, into your crossing or plotting of your cross sections. So yeah, we're going to define the left edge for the left carriageway. So it's your right Layerwork edge, and we're going to use that existing yellow line left. Okay, and on the right carriageway we're going to use the left Layerwork extremity and its existing yellow line right. Those minimum layer is going to be 500, so just to get your compaction, whatever you're using to do your compaction to get into that trench, you need a bit of space. Okay. So there you can see the Layerworks have only been drawn from the edge of the Layerworks to that yellow line, and then we've restricted it on the right hand side. Okay, so it doesn't actually run past the yellow line. So we've just contained those pavement Layerworks, and we're only displaying it in that section. And that minimum layer width would have been 500 to make it a more practical application. Okay, so those will be used for your volume calculations, solidify Layerworks, and your cross-section plotting. Okay, now I'm going to move on to adding the components in your edge levels. So we're essentially looking at this chainage 1700 to 1900 area on that left widening, and I'm going to be looking at adding a V-drain and a retaining wall in the left cut and fill area. Okay, so we're going to have to add another column, and to do that we would right click and append a component. Okay, and then just you could either scroll down to that chainage range, or in this case I'm going to select the chainage range on the plan, and then it's prompting me for the start point, and I'm going to run it from 1720 to more or less 1860. Okay, it's one section there that you're going to got. Okay, I missed 1720, but it's fine. So I'm going to have to add in the component that I want to use. So to do that, I'm going to right-click Load Component, and I need to select the V-drain. Okay, there is the retaining wall for cut, and then just the Sunroll 500 V-drain that I'd like to use. Okay, so I just check those two, and I've got them now available to use. I'm going to right-click and edit those cells, and then add the V-drain firstly. Okay, it's a Sunroll 500, and then we have to append again just to add another column. and I'll highlight that same range. Just keep my shift key in, and once again we want to edit the component for the selected cells, putting in that retaining wall. Okay, then just in this case, the slope on my left edge to tying with the retaining wall, I'm going to make that a 0 slope. I'll touch on the functionality with the retaining wall later, the component. We'll go through how to set up this component that it intersects with your ground. Okay, so I'm just setting all those slopes to 0 along that chainage range. Then I'll close and save, and okay, just to recalculate. Okay, so we've added 2 components, and this would be the one way of doing it in the edge level spreadsheet. You can do a range of chainages. Let me just go and have a look at that in the cross-section. That's cross-section graphical edit. And there you can see the drain has been added and the retaining wall up to chainage 1860. Okay, I'll just have to look at 1720, and I think 1880 we might need to add another drain and the retaining wall at that chainage as well. So the other option is to do it in the cross-section editor, so we can have a look at that section graphical edit, and I'm just going to look at that component panel, the component panel, which is the last icon on that toolbar, and we're going to slot in the V-drain. Well, I just need to repair, in this case, the retaining wall, and then just check my slope. Okay, so that's fine. And then if I page down, I'm going to want to recalculate. I'm just going down, let me save that, yes. And I'm paging down to chainage 1880, and once again using that component panel to add in my component, and I'm inserting 2 additional lines to add your components, and then I should be able to, I just have to resize this, my screen resolution. Okay, so it's the sunroll V-drain and then retaining wall, and just check my slope as well. Okay, so that needs to be 0 just to tie in with this intersecting retaining wall. And then I'd have to save and let it recalculate. So that retaining wall, in this case it's a variable height retaining wall that we've added it into our standard components. Okay, so if I go through that chainage range, you can see that the retaining wall actually is being sized as it goes along and just intersecting with the ground. So maybe I should just touch on those new special vertical movements that we've incorporated for that variable height retaining wall. So if I go to the components, sorry, it's the template editor. I'm just going to run it through the template paths, template editor. Okay. I'm going to look at adding, so on the left cut condition, we're going to add in that retaining wall. So just to get it to actually intersect with the ground, you have to add an edge first. So that's the trick of this using of this component. So 0 horizontal, but my vertical I'm going to make ground intersect. Okay, you guys are aware of the previous 2, that 777, 888 shortcut or vertical code. So this one, if I look at the data tab, it'll equate to the 666 code. So that's a new code. It means to intersect with the ground. Okay, and then if I go find that retaining wall component, It should be linked to this particular project because I've just used it. It's in the template tab. Under the components, it's the retaining wall, the cat retaining wall. And then I can drag and drop that in. If I drag and drop, the advantage with, sorry, just let's have a look. If I edit, I just want to show you before I do that. The 555 code is the other one that we have, and that is to extract to next. So you've got a positive extract next, and the vertical, that line 5 will be the vertical extract next, the negative extract next. Okay, so that gives us the ability just to resize that component, and then in conjunction with that 666 vertical movement, it then ties into the ground. Okay, so there I'm slotting it in. Okay, and when you drag and drop, at least you can drag and drop it at any specific point. I'm going to right click and mirror the assembly to the right hand side. You guys should be aware of that mirror option, so you can design everything on the one side and just mirror it across. Okay, and then I want to test those resizable variable height retaining walls. Okay, so I'm just zooming in, and then I'm adding ground. We can do a high section, and then I'll go across through the median. Remember, it's that ground intersect median condition, and then a slightly lower retaining wall escape. And you can see how the two retaining walls have stretched up to the ground, intersected with the ground, and then we followed the ground through the median as well. So that's a really nice function that the guys have added, the extract and the variable height component as well. Okay, so close that. I'm not going to save the changes, and then okay. Good. You guys still enjoying the webinar? It's interesting stuff we're working with. Okay. All right, I'm just going to close my control center, and then we're going to move on to the next project. I'm using my wellbed overall layout project. You guys have probably seen this, and this is to look at that linear bar mouth grading. Okay, I'm just changing my cross-section road to a string road here in the properties bar, and then I'll just have to recalculate, so clear selection and recalculate the road. Okay, so just to convert it to a strings road. And then what I'll be doing is just adding an intersection and checking out that linear bar mouth grading. So let's just have a look at the vertical alignment. I've already adjusted that intersecting roads grade so that it ties in at the same crossfill grade of my main road. Okay, and maybe just to also show you the intersection tie-in point, I'm just changing the color to blue so you can see where it is. Okay, it's always nice to be able to see which grades you're tying in with. Okay, and then I'm going to run the intersection. So if we go to the Junctions pull-down menu, add intersection, select my intersecting road and the main road. See the left and right curves. Remember that convention is you stand on the main road looking down the intersecting road. So left is that side and then right is on that side as you're looking down the intersecting road. Okay, so we got these two options as far as defining your bar mouth, enter curves and tapers or extract from CAD entities. So you guys are aware of that. In this case I'm just going to stick with the left and right central radius, and then you'll see these edge conditions. Darby has put in a new none option over there So that allows you to do a linear grading from the one road edge to the other road edge. Okay, so just to touch on those gradings of the bow mouths, we normally do a crest curve or a sag curve, and then you've got the S-curve grading. So if you've got two rising grades, it's a crest curve, two falling grades, it's a sag curve. But I'll just leave it as the S-curve for now so we can see how that works. Okay. And let it recalculate and run the intersection. And this one, because of that incoming grade, I've also changed my crossfill grade, so everything should tie in pretty smoothly and at good speed as well. So I'm just going to show you that bow mouth grading there. So you can see those are two climbing grades. They're intersecting, and we've put in that crest curve. Nice smooth curve. Okay. Just close that. And then I wanted to show you if we edit the junction and use that none option and try the linear interpolation. Let me just get the intersection. So I'm editing again, and I'm looking at that left side. So remember, looking down the intersecting road on the left curve. And I'm looking at the edge condition, changing it to none. Okay, I'll just leave everything else as is. Okay. Let it recalculate. And then we can have a look at it again with the bow mouth editor. Okay, so that's the new linear grading. If your bow mouth was defined with the 3D CAD polyline, it could actually pick up the levels from the 3D CAD entity as well. So in this case, it's just a straight linear interpolation. You can do those inside that editor as well. Okay, so the right one, we just had that CAD, sorry, a bit of a sag curve in there as well. All right, so those are the two options, either that normal S-curve or the none. And let's just look at it in the nice render view just to verify your design. The render is linked to our CAD module. You can see that's pretty smooth. Yeah. Nice smooth time that we've got. Okay, I just want to edit the junction again. I'm just going to go back to the S-curve grading on that left bow mouth. Okay, edge condition, S-curve, and then recalculate. Okay, so it's recalculating. And then I'm going to show you, let's have a look at the display settings, the road strings. We can look at the contours, the interval 0.1, and my slope arrows. Okay. You can see those contours blend in pretty smoothly through that intersection. See order direction. We've also got those drainage displays that you can see where your catch pits and low points are. I'm just going to switch that off for now. Okay, so that was a linear bow mouth grade that we used. Alright, so the next item on our list today for this webinar is the automatic intersections. I'm just changing to our normal tutor project, and I'm selecting the road file. Okay, I'm going to add a new road. You can see we've added a whole lot of additional roads to our tutor project. Okay, just to check which template, it's the single 16, okay. And okay. And then I'm just going to look at the option settings. So to activate the automatic intersections, you have to go into the file option settings, automatically add intersections, the checkbox. That's the tolerance. It's the search distance from your center line to the start to end PI, and then we want to see those settings. Okay, so when it runs the application or the function, then it'll show you the radius that it's going to be using, and you can always edit that in those settings. Okay, so these automatic intersections get inserted with the graphical editing. So I'm just graphically inserting an alignment through this road reserve over here. I'm going to use the circle. I've got a circle defined over there. That'll be my start PI. Okay, and then just put in an end PI on the other side. Okay, that's my end PI. Okay, I'm just going to let it run with that vertical alignment. So I'm just going to let the road expert finish the design with the information out of the control panel. Okay. So there we've got our alignment. Let's just use that standard urban single template. And then if I go graphically move that start PI, just to show you, once I start editing the PIs, then it's going to activate those automatic intersections. Okay, so if I deselect now, clear selection. Okay, I'm just going to ignore that change. And then you can see in the prompt area now it's read in that there's a main road in the proximity of my start PI. I'm just going to use that 10-meter radius, and then it should pick up on the end PI as well that there's a main road, and it's giving me the same settings. Okay. If you don't have a main road at the end of your this road that we've just designed, then the option is to add cul-de-sacs. Okay, so I'm just going to add a road on the edge of the tutor project. Just put in another road file quickly, select a road file, new road with the same settings, the same template. Okay, and then I'm just going to graphically insert another alignment. Okay, horizontal graphical insert, just to show you how it does the cul-de-sacs automatically on the ends. Okay, so once again, just to start PI, I'll put a horizontal curve in this road. Let's just add a second PI there. Okay, I just need to keep it away from the existing road so it doesn't find a main road to intersect with. That's my end PI. Okay, and then just let the road expert once again finish the calculation and design the road. I'm going to just keep it following the start and end PI vertical alignment. So if I once again go alignment horizontal graphical move or edit my alignment. Okay, let me just smooth out this curve, the horizontal curve. I'm going to put in a radius of 20. Finish that. Just let it recalculate. Okay, I probably might need to use a slightly longer radius, but let's go and just move one of those PIs. In this case, I'll move the end PI just to show you. It'll then give me the option to insert the cul-de-sacs. Okay, so I just edited it graphically, and there's the option now to add the cul-de-sac. I'm going to make it 7.5, and then I'll run that. So it's going to add the cul-de-sac at the start and at the end of the road. So that's the new automatic intersection functionality. Okay, and then the final item we're going to be covering today on this webinar is the water film thickness or Sheetflow Analysis. So this function will calculate water film thickness along a road surface for specified rainfall. So I'm going to use this dual carriageway road, which is Keerboom. Okay, and I'm going to be using the tools, the water film thickness function. Okay, you can set the chainage range. I'm just going to make it relatively short, and then I'm going to leave the rainfall at 100 mils per hour. Okay, and then that depth is 2 millimeters. So anything deeper than 2 millimeters will be highlighted in red. So this is quite a calculation. It's going to run through because of the dual carriageway. It's going to do both the left and right hand carriageways. So this water film thickness function calculates the steady state water film thickness. WFT is the acronym, at grid points along a road surface for a given rainfall or specified rainfall. Water film thickness is a big contributor to hydroplaning. This Civil Designer water film thickness function will allow you to identify potential hydroplaning, aquaplaning sections of your road. You will then obviously be able to go and modify and design, or modify your design and rectify these problem areas. The optimum chainage range for a realistic analysis is between 200 and 400 meters. It depends on your road properties, your road widths and crossfalls, and then a maximum of about 1,000 meters is generally recommended. Okay, so it's run both sides, and you can see, if I zoom in a bit, the shading it's done. So it puts in, for all those little grid blocks, it's put in the depth of water from that rainfall that we've experienced, and then it shows you the flow direction as well. So anything more than 2 mils is the problem there. You can see shaded in red. And if you guys want any more information about this Sheetflow analysis, we have a technical paper that we can give you that explains everything in detail.
We'll be planning our next webinar on the 29th of June, when we will be demonstrating either our new water design or 3D CAD animation functionality. Please let us know which of the before mentioned you'll prefer by emailing us on info@civildesigner.com. Please also visit our Civil Designer Software YouTube webpage, hosting a number of feature highlight videos, including the road rehabilitation and Sheetflow analysis functionality covered by Andrew today. Once again, ladies and gentlemen, thank you very much for your valuable time this afternoon. As I stated earlier, please email us using info@civildesigner.com should you wish to arrange a focused on-site or online interactive user group for your individual office or team. Have a great weekend. And please always ensure you're using the latest version and build of Civil Designer, which is version 8.1, build 5. Take care, goodbye, from Civil Designer's head office here in Cape Town.